Hi guys, I'm Ankit. In this video we shall see another problem on LeetCode. Maximum consecutive ones. So given a binary array and integer k, return the maximum number of consecutive ones in the array if we can flip at most k zeros. So they are given a value k and you can, if k equal to that means you can flip at most two zeros to 1. That is what they mean. So if we take maximum consecutive ones present in the array, the first three, and the next two, if you reverse these two into one, because maximum two zeros can be flipped. So that will be total of 5 length. But if we check again, move ahead and this array, till here on you can do because three consecutive zeros you cannot flip it to one. Then let's say this array, two zeros and four ones, so that will be of 6 is the length. Similarly, if we take the last array also, two zeros you can flip at most and also four ones. So in the sense total of six ones are present in array. So maximum consecutive array you find the length of 6. So this is the problem. So what is the approach to solve the problem? So as you could see here we will be using the sliding window technique. So what we'll do is we will have two pointers. Okay, so let's say I and j. How do you find the length? If I is pointing here and j is pointing here, let's say this is a 0, and write the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 minus the index at this position is 5. 10 minus 5 plus 1, 6. So j minus I plus 1 will give you 6 as the length. This is what the answer we need. Or else 9 minus 4 plus 1 also you can do. From this 0 to here 1. 4 to ninth index. That also possible. So how do we get this answer? So first we will have, as I said, sliding window node. Two pointers we need to have I and j. That both be pointing to the beginning of the array, and we will have a variable called maximum count. Or let's say let it be just count. Okay. Initially it is 0. And in the every loop we will be finding count equal to max of count and this window j minus I plus 1. So initially I and j both are pointing at the beginning. So j minus I plus 1, 0 minus 0 plus 1 will give you 1 as answer. So count will be 1, maximum count. Next increment j pointer now. If array of I is equal to 1, just keep on incrementing the j pointer. Here array of I equal to 1, so you increment j pointer. Array count will become 2 because I minus j plus 1. 1 minus 0 plus 1 will give you 2. So again you move the j pointer because array of I is 1 here. So count will become 3. Then again you move the j pointer because array of I is 1 here. So at this point you found the value is 0 over here. And the value is 0, k equal to 2 they have given. Okay. So the value is 0 and k equal to 2. So you have to check when the array of I, that is nums of I, not I here, j is equal to 0. We have to check if k is greater than 0. If k is greater than 0, yes, you can flip this 0 bit to 1. So that means we'll again add it to the count again. So in this case, what we have to do is k minus minus. K will be decremented as you flipping this 0 to 1. So this 0 is flipped to 1. So count will be again 4 it is. Count will get incremented. Then again you move j pointer here. So from 2 it will become 1. Again you check whether nums of j is equal to 0 and k is greater than 0. Yes, it is k equal to 1. So again k minus minus you do 0. And count will also be, as I said, count you have to find computed every loop. So max of count comma j minus I plus 1. 4 minus 0 4 plus 1 5. So yes, count will be 5 because max of 4 comma 5 is 5. Again you increment j now. Now at this point, what you can observe. So let me just erase all this. So at this point, what can you observe? Nums of j is 0. And if k is greater than 0, is it greater than 0? No, it is equal to 0. That means there are no more zeros you can flip in the array. So what this time we will do is, here else part comes in. If k is greater than 0, until you find the next 0, until you find the next 0, that is this 0, you're not actually flipping it, you're just assuming here to flip the bits. Assuming that you're flipping the bits because k is greater than 0. So you will not be actually flipping the bits. So I'll erase this. Okay. Until you find the next 0, you should be incrementing the I. So while terms of I not equal to 0, what we need to do? I plus plus. Is nums of I equal to 0? No. If it is not equal to 0 means what can be done? You just need to increment one pointer, that will get to know. Just increment point here. You also not equal to 0, not equal to 0 point. When you come here that this version 3, nums of I is equal to 0, hence you stop the loop, you won't increment. But actually, can you take the size j minus I plus 1 now? But it contains 0 consecutive 3's, no? 3 consecutive zeros. So for this, what should be done is after the loop also you just have one more I plus. That means once you encounter 0, you stop the loop. Then you have to increment one more 0 because this case happens only when the k is equal to 0, right? When k is equal to or lesser than 0, less than 0 won't happen. K is equal to 0 case it will happen. So that's the reason. If you count this I, j minus I plus 1, 5 minus 3 plus 1 will give you 3. The length 3 is not proper because 3 consecutive zeros are present. But we can have only 2 consecutive zeros. We can flip it, right? So what we do is you do I plus plus. If in case, let's say, as I said before only, let's say this beginning of the array itself is 0. Okay. Now you have the pointer over here, I. Well, nums of I is not equal to 0, but it is equal to 0. That means you should just increment. So this loop will not run. You just increment I plus plus. I will move here and find the length. So until you get the next 0, you just keep on incrementing. Once you get the 0, you just have one pointer ahead, more than one pointer ahead from 0 to next, and then you find the length. So that is what we need to do. So for now, we have the pointer here. So now j minus I plus 1, what is it? 5 minus 4 plus 1 will give you 2. So is 2 is maximum of 2 comma 5 is 5. So keep the count is 5. That's why I said every loop you have to check. Otherwise you will lose track of the maximum length. That's the reason. So now again you increment j. Next loop you go. Again increment j. It's equal to 1. So again I minus j. 6 minus 4 plus 1, 3 is the length. But 5 is maximum. Again increment j. 7 minus 4 plus 1 will give you 4. But 5 is maximum. Again increment j. 8 minus 4 will give you 4. 4 plus 1, 5. So 5 is the max count. So again increment j. So this time it's 9 minus 4 will be 5 plus 1, 6. So 6 comma 5, which is maximum? 6 is the length. So this is the maximum length. 6. Now again you increment j. This is j. The j is found here, you could see 0. Right? Terms of I j equal to 0. But if k is greater than 0, no, k is still 0 because two zeros we have already flipped, we have considered it as already flipped and considered it as 1. So we cannot have more. So again, what you have to check else part, nums of I not equal to 0. Is it not equal to 0? No, it is equal to 0. So just increment one pointer. Now if you increment, so what you will have is, so what we are having is, there one pointer having I here and one pointer j. Is it okay to have consider this 0? Yes, because 1 0 is here, 1 0 is here. If I is pointing here, then it will be 3 zeros. So you just increment one pointer I plus plus to have 1 zeros to decrease the count of this 0. So now 2 zeros and we are flipping that to 1, that is okay. Now find the length. 10 minus 5 plus 1 will give you 6, which is already 6. So either you can have this is consecutive maximum consecutive array or this is array. Any one of them works, but they have asked only for the length. If they tell how many are found, the maximum, then you have to take count of this and this. That will be 2. How many maximum consecutive array are found? So this is a approach to solve the problem. Let n be equal to nums dot size and we'll have variable I equal to 0. For j and I equal to 0. j equal to 0, j less than n, j plus plus. And yeah, j we are incrementing at every loop. Whether I increments or not, that doesn't matter. J will be incrementing every loop, but I will increment only if you found like zeros are exhausted, like k is exhausted, and in such case you will increment I till you find next zero. So this is the result. So now if should we need to take consider like nums of j equal to 1 max count equal no, no need to take that. We'll take only this case into consideration. So nums of j it is equal to 0. First what we need to check if k is greater than 0. If k is greater than 0 then it's fine, just decrement the k value. That means you're flipping that particular 0 value to 1 in that position. Else what we need to do until you find next element equal to 0, just keep on incrementing I, and one more I should be incremented. As I said, once you found the 0, no, that is not fine. You have to increment one more position so that exactly two zeros are only flipped here. So after that, in every loop, so this is sequence. In every loop, you have to find a count equal to max of count, comma, j minus I plus 1. I have not defined it. Okay, let me define. Let count be initialized to 0. And at the end, just return count. Okay. Yeah. And yeah, for Java also the same approach we'll be using. I'll show Java. Yeah. Same approach, same logic, only math.max and instead of size we use length here. Submit this also. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Till then, keep learning. Thank you.